force. That means if we know one quantity, we can say that the force is proportional to that. Okay, more the force to apply for stopping this car, we need, that means this car possesses more momentum. Similarly, if this car possesses less momentum, that means we need to stop it with lesser force. We can stop it with lesser force. Similarly, this is a small stone and this is a bigger stone. We can say a rock. Okay, if these are dropped down at some height, this will also possess momentum, this will also possess momentum. So we can say that this body possesses more momentum, this body possesses more, and this body possesses less momentum, because we know that on coming to the ground, upon touching the ground, this will have more effect upon the ground, or whoever takes these rocks into the hands, he will feel that more force is exerted by the bigger rock than the smaller rock, smaller stone, because this possesses less momentum and this one possesses more momentum. Okay, so that's why the force exerted by this, or upon touching the ground or the hands of any person, he will feel the force exerted by this very rock is very, very larger in effect, I can say, as compared to that of the smaller rock. Similarly, so we can say apply for other objects as well, but here what we got from these two examples is that momentum has something to do with masses. Okay, which is quite observable from the derivation, also from the formula of momentum, that P is equal to m cross v, mass multiplied by velocity. So that means more the mass possessed by the body, more will be its momentum, and more will be the force exerted by it. Or to stop it, we need more force, and we have to exert more force. The lesser the momentum, the lesser the force. Similarly, another example, say a stone or a marble. We pick up a stone or a marble inside our hands and try to throw it on the wall. What will it do to the wall? Maximum, this marble will itself break down, or it may cause some scratches on the wall. But if the same mass, this is mass m, if the same mass of a bullet, this is a bullet, is fired, okay, is fired on the same wall, maybe it may burst into the, it may try to go inside the, deep inside the wall, causing a bit more damage to the wall. That means the only difference here you can see that is that of the velocity, because maximum velocity of the marble is even much smaller as that of the bullet velocity. So we can say that more the velocity of any object, the more the force will be exerted by it on a particular thing. So that means the more the momentum will be it possessing. Okay, so that means the more the velocity of any object, more will be the force exerted, hence more momentum. Okay, so more force will be exerted, that means the more momentum it will be possessing. So that means momentum also depends upon the velocity or the speed. Fine. So in that case, in the case of marble, it is moving with much lesser velocity, so it will be possessing much less momentum. but the bullet, it will be possessing much more velocity, so causing much more damage to the wall. So that means it is possessing much more momentum because it is exerting a much more force on the wall. Okay, so that means from these two examples we can get that momentum is dependent upon the mass. More the mass, more the momentum possessed by the body, and the velocity. More the velocity possessed by any body, more will be the effect of force, and more will be the momentum. Now, another thing where it is dependent upon is the time of action. The time of action.